Let's talk about adding and subtracting roots and radicals now. Adding and subtracting is different than multiplication and division. Multiplication and division, you just needed the same radicand, the same base number. But when you're adding and subtracting radicals, they have to be like terms. So they have to have the same index number and the same radicand. Let me show you an example of that. If I had 2 cube roots of 4, and I wanted to add 3 cube roots of 4. I could add those together because the cube root of 4 and the cube root of 4 tell me that I have like terms. So 2 cube roots of 4 plus 3 cube roots of 4 would be 5 cube roots of 4. If anything about this was different than this, I could not add them together. So for instance, let's say I had 2 cube roots of 4 plus 3 cube roots of 5. Can't add them together. They're not the same. Everything about this has to be the same as this. So let's do a couple of examples. And I'm going to start with one where they are not the same and show you how we have to make them the same. So I have the cube root of 16 subtract the cube root of 2. So in order to be able to subtract them, this entire thing has to be the same as this entire thing. So I'm going to have to work to see if I can make them the same. Since this one's the cube root of 2, it's the most simplified, I'm going to see if I can make that one the cube root of 2. So I'm going to try to break down 16. 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. So I notice here I have a group of 3 2's. So that's going to put a 2 on the outside and leave 1 2 on the inside. So I have 2 cube roots of 2, and I'm subtracting 1 cube root of 2. So my answer would just be 1 cube root of 2. And since it's a 1, I don't have to put the 1 there. It's understood. Okay, let's do another example. Number 2. The cube root of 625 subtract 2 cube root of 5. So since this is the smaller one, I'm going to see if I can turn this one into a cube root of 5. So I'm going to try to break down 625. 625 goes to 5 and 1, let's see here, 5 goes to 5 and 125. And 125, I've done this one several times, it goes to 5 times 25, which is 5 times 5. So this has 1, 2, 3 5s, so that'll put a 5 on the outside and leave a 5 left on the inside. And some of these we're going to get memorized. Minus 2 cube root of 5. So I have 5 cube root of 5, subtract 2 cube root of 5, which is 3 cube root of 5. Here's the third example. 2 square root 2, subtract 3 square root 2. They're the same. They're both square root 2. So I have 2 of them. I take away 3 of them. That leaves a negative square root 2. That one was fairly easy. Let's do this one. Negative 3 square root 6, subtract 2 square root 5, plus 3 square root 5. So again, I'm looking to see if I have like terms. I do. These are like terms. They're both square root 5, so that means I can put those together. And 6 just breaks apart to 2 times 3, so there's no way I can make it a 5. So I'm going to put these two together and leave that one. It's not the same. It's not a like term. So my answer would be negative 3 square root 6. And I have negative 2 of these, add 1 of these, and that leaves me a positive 1 of those. So it's negative 3 square root 6 plus the square root of 5. Okay, let's do the next one. Number 5. I only have 2 more. Number 5 is this. 3 cube root of 40. Now I'm going to get a different piece of paper here to make sure I have room. go with this. 3 cube root of 40. Subtract 2 cube root of 32. Subtract 2 cube root of 40. So they're all cube roots. So if I can make them the same number underneath here, then I'll be in good shape. Now I notice all of these numbers factor. So I'm going to start by seeing if I can get them to factor. This is 3 cube root of, and I'm going to use 8 times 5 because I've found that 8 is 2 times 2 times 2. So I'm going to memorize that the cube root of 8 is 2. So if I can break it into 8 times something, that's good. And 32 is 8 times 4. And cube root of 40 is 8 times 5. So every time I see a cube root of 8, I'm going to cross off the 8 and put a 2 on the outside because the cube root of 8 is 2. So that's going to bring a 2 on the outside, and that's going to bring a 2 on the outside. And the 2 that I brought to the outside, I'm going to multiply times the number that's already there. So this would be 6 cube root of 5. I'm going to multiply the 2 that's already there times the 2. So it'd be 4 cube root of 4 minus 4 cube root of 5. Now 4 breaks down to 2 times 2, which isn't going to be enough to bring anything outside the radical, so I'm going to leave it. So now I'm looking for like terms. I have a cube root of 5 and a cube root of 5, so I can put those together. That makes 2 cube root of 5. Subtract 4 cube root of 4. These are not like terms, so I can't put them together, so that's my final answer. All right, last one here. Number 6. Move down the page. Negative 2 fourth roots of 162 plus 2 fourth roots of 64 minus 3 fourth roots of 324. So I'm looking for things in groups of 4. You may have to do a little side calculation here. I'm going to start off with 162 and see if I can break it apart. That goes to 2 and 81. 81 is 9 and 9, which is 3, 3, 3, and 3. So I have negative 2 fourth roots of 2 times 3 to the 4th. I'll just leave it like that. Okay, what about 64? 64 is 8 times 8, which is 2 and 4, which is 2 and 2. And 2 and 4, which is 2 and 2. So I have 1, 2, 3, 4, 5, 6 2's. And 324 goes to, let's see here, what goes into there? 3 does. 3 goes in 108. And it doesn't matter what numbers you choose, we should get the same answer. This goes 3 and 36. That goes 3 and 12, which is 3 and 4, which is 2 and 2. So I have 1, 2, 3, 4 3's and 2 2's. So now I'm going to go look for things that will come outside the radical. I'm looking for things that happen in fourths. So 3 to the 4th is going to bring a 3 out here. 2 to the 6th, that's going to bring a 2 outside, but leave a 2 to the 4th on the inside. This is going to bring a 3 out here. So here's what I've got. Negative 2 times 3, which is negative 6. Fourth roots of 2. 2 times 2 is 4. Fourth roots of, I had 2 to the 4th brings a 2 out, so I think I have 2 squared left in there, which is just 4. And then here, I had 3 times 3, which is 9, fourth roots of 4. So I'm looking for like terms. These both have like terms. Sorry, this got a little messy here. So it's negative 6 fourth roots of 2, and then minus 5 fourth roots of 4.